Okay, for the Whoosh bottle demonstration, first I'm going to start out here with some ethanol. Ethanol is an alcohol. It's got 2 carbons, it's got 6 hydrogens, it's got 1 oxygen. I'm going to pour some on the table here. And one of the chemical properties of ethanol is that it combusts or burns. So let's just watch that. There we go. Kind of burns with that nice yellow flame, which tells you that it's not burning particularly efficiently, so it's not really very hot. All right. Notice it's only burning from the surface. All right. It's not exploding. Again, in order to burn, what do you need for something to burn? You need oxygen. Where's the oxygen coming from? Oxygen is coming from the air. All right. Burning kind of nice and slowly. Not hot enough to do any damage to the table. There we go. The last little bit of ethanol is going. Bye-bye. There it goes. Last little flames are out. Okay? All right. Okay? So that's just burning alcohol. The rate of that reaction is dependent upon how quickly the oxygen can access that surface on the ethanol. And yeah, we're going to show you a different way to burn ethanol. I've got this big bottle here. Okay? I'm going to take and add a little bit of ethanol, not too much, just a little bit of ethanol to this big water bottle. All right? Just a touch. Okay? We're going to put it in there. And now, what we're going to make sure that we do is take and rotate that ethanol, disperse it so that we coat the walls of this bottle as much as possible with the ethanol. As we're doing this, we're helping to promote the ethanol vaporizing going into the gas phase. So in addition to having lots of liquid ethanol in here, we've also got the gaseous ethanol. We also have lots of oxygen in here because that's just in the atmosphere. We're going to dump out the excess liquid ethanol, right? And there we go. Get most of that liquid out of there. Now we're going to invert the bottle, okay? And we're going to see a slightly different reaction. There we go. Very different, okay? You can see the combustion just stopped there. What was the difference? All right, same stuff, same chemical reaction, but we made it proceed much faster because of the fact that we had ethanol in the vapor phase, oxygen, they're right next to each other. So when I ignited that, boom, it went off, okay? And it generated enough gas and heat to give you that nice flame shooting out of here. And then you may have noticed a little bit of oscillation back and forth as the residual ethanol in the bottle combusted, okay? Now here's a trick. I may have waited too long. If I put my finger or hand over this, I think I waited too long. But if I had immediately put my hand over this, as the bottle would cool, it would collapse. But I wasn't fast enough, all right? So be a little faster next time. If you're going to do the experiment again or use a different alcohol, what you first need to do is you need to rinse the bottle, okay, with water and let it cool. If you put the ethanol back in here right now, what happens is the ethanol has a tendency, because this bottle is warm, the ethanol has a tendency to vaporize and sit on the top. And now when you ignite it, you don't get the whoosh effect. You actually get burning ethanol up here. That's why the top of this bottle is open. All right, so that's the Whoosh bottle. You can do it with different alcohols. You could do it with methanol. Methanol is the best, but a little hazardous because it's the most volatile. Yeah. Ethanol works, isopropyl alcohol works, even 70% isopropyl alcohol works, so you can compare the 3 of those if you wish. All right, that's my Whoosh bottle.